good morning, good afternoon, and good evening, everybody. Welcome on into the Dragon's Den. Digital Dragon for most of your Saturdayers. We are a little bit wired, starting to get that way. Got Black Rifle Coffee Company cup, which holds 2K pods. So we've got Cactus Squatch starting off. Got a backup mug with some Freedom Roast and Just Decaf to try and help mellow me out in the background. And I think Mrs. Dragon just left to finally make the morning Dunkin' run. It's going to be sugar-fied and wired here, which is probably going to be a good thing because we need to get some stuff done today on the black box. And I just remembered, folks, give me 1 second. I'm going to step down to the garage real fast because I need the vise. That will be critical for today. So give me 1 second. I will be right back. Okay. Yes, we're going to need the bench vise today because we need to straighten out the wires. And by the wires, I mean the spring steel wires that we'll use for our umbilicals. So we are going to need that. We'll need our drill, which is right underneath the workbench. And we should be using some safety squints and gloves. I've got my glasses. They are properly rated. But make sure, literally, and I mean this wholeheartedly, make sure you've got eye protection on. Do not just, safety squint, I'll be okay. This is going to be spring steel wire. We are going to be trying to twist it and do things to it to straighten it out. We'll be under some tension and some pressure. So just be careful and keep, protect your eyes, protect your body. Getting little cuts and stuff is one thing. Catching yourself with a burring tool and having to put a Band-Aid on, that's one thing. Getting stuff in your eye, never a good thing. Well, welcome on in, everybody. Mr. Wizix, Timor, Killer Dragon. Welcome on in this morning. You'll notice that there's not a printer right in front of me. That's because I had it up here and then I took it back down. So we've got the black box is sitting right here. I will have to ugga dugga oof that up onto the table here shortly. And then we've got the DZ-Bot build that we've been working on. So let me bring that up here and just show this off right quick without having the coffee cup. So the VZ-Bot, we made some good progress on this Thursday. We've got our front little wing panels done up. So we got our front little wing panels screwed in. We'll have the door hinges up at the top. Door hinges will go in at the bottom as well. Left those off for the time being until we get the rest of this done. I need to print the actual knobs that we'll use at the front of the machine to do the tensioning for the belts. I did reclock the Goliath, so now the hot end wires and the thermistor wires are going to be coming out the side. We did work on getting the deck and back panels on. So we now have the beginnings of our electronics panel. We've got the exhaust fan here. And the thing that I noticed there are no pre-drilled holes for the DIN rails. So we are going to have to put holes in this. Trying to figure out how I want to put holes in this, because I would really rather not take this plate back off and disassemble some of this stuff to put holes in it. I know that Steve Builds has some jigs for drilling. I may just kind of lay it out, make sure I kind of like where it's laid out, punch holes, and then drill holes out and deburr it in place. Making sure, of course, to have a catch basin to collect all of the metal shards so it doesn't get into electrical components. But we are going to need two little stub DIN rails on each side, one kind of in the middle to hold our board. But this is going to be the inlet, so our CPAP blower sits over here, and the hose is going to come in through here. But yeah, this is coming together. It's looking really, really good. It's getting heavy, 3 mil sheet aluminum for the back and the bottom deck panel. She's getting heavy. She's gained weight. Get her back off there. And then of course we have Blackbox, and Blackbox sitting down here is definitely weighty. She's probably close to 90, 95 pounds now. Because we've got the bed on there. Well, remember on the Blackbox, we had about 80 something pounds of material that showed up. That was 80 pounds of material, not including the 5 tool heads. So, you've got the water blocks, the cooling blocks, the metal plates, and all of the bits, bobs, and gubbins that make up a tool head. So we've got kind of, like I said, she's heavy, and once we add water, she'll get a little bit heavier. Not sure how much water she'll take. Might be something, because I didn't see anything about how much water it'll take. But that's something that's going to be worthy of note, because you probably do not want to transport her full of water. Means whenever I go to take her to shows, I'm going to drain the water out and have to take water with me to cool it at the show. Hey, Tugboat, good morning. Tugboat, you may have seen some posts on Twitter last night, but this was how I spent my Friday evening. Okay. This is 2 complete sets of frames for our Rook 2020s. The 4-pack will have the blind joint holes done in them, and the 2 of them only have blind joints on the one side, so those will be the front uprights. So all 4 of the bottoms will have both sides drilled, so you'll have a hole on all 4 faces. But the top front pillars only have the one front face. And then we've got the 7 200 millimeter rails, and I did the best I could to blow them out and wipe them down to get as much of the milling chips and stuff off of them. But there will probably be some still left on there. But I got both sets of those done last night. I'm printing skirts and a couple of other pieces right now for both of ours. And I'm printing, I've decided I'm going to print the both the AC inlet and the DC power brick inlets. And we're going to have to figure that out as we go. And the reason being, you may have also seen another tweet that V0s and the LDO polyimide V0 beds. So an LDO V0 kit or a LDO bed that uses the polyimide heater was coming with a Morn Sun LMF 200 24 volt 200 watt power supply. Well, Morn Sun as a company, the company that makes Morn Sun, has been added to the U.S. sanctions for providing material to Russia in the Ukraine war. So I'm not sure if they can distribute or sell kits that are already in the United States. So I'm not sure if KB3D will be able to ship you an LDO polyimide bed with a Morn Sun power supply because it comes as a prepackaged kit, or if we will have to go out and get Meanwell power supplies, or go with the power bricks, because the Meanwell power supply does not fit underneath and enable you to actually put skirts on it. Okay. So that's we're going to have to do some troubleshooting at this point is where I'm getting at. Having a separate power brick isn't that big of a deal. It just means a little bit of additional wiring underneath the panel. And the fact that you need to remember to not leave behind the power brick. And I would always say, have your primary and a backup power brick, because if the fuses in one of these power bricks let go, you're not gonna. It's not an easy fix. So we'll continue to work on that as things evolve there. A couple of things that we need to do today is going to be to finish up a little bit of wiring on the tool head. That's just some additional crimp connectors, and that's another reason Blackbox is not here on the bench today, because we still need to solder some wires on our end stop. So I specifically don't have Blackbox here, so I can bring the other camera over. We can do some soldering today and get some pigtails soldered on. I want to say yeah, we were using blue and black, so I'm gonna have to grab some blue and black wire. I'll probably go long and then cut it short to make the pigtail. So we'll be doing a little bit of crimping, a little bit of soldering this morning, and then yeah, if you just plug a cable directly in, then you're putting mains voltage into a DC rated connector, and it poof, and your board goes poof in a spectacular fashion. You will blow every cap on there until it finds a dead. So I can, on Tuesday's stream, or actually Tuesday we will definitely be streaming. I may stream on Monday because I have Monday off. So unless Mrs. Dragon identifies a honey-do list for me on Monday and it's not raining, then I might be streaming some on Monday. But yes, let me show you something real fast. So this is the UTC. I've got a note on here that says took 120 volts. Kind of hard to see with the lighting here. And I'm not sure if the UTC reflects it or not. Yeah, I'm not seeing anything on the UTC other than the fact that um, it will not flash anymore. So one of the things I keep this around for, because it is a dead board at this point, I keep this board around specifically for doing mock-ups and to verify my wiring here. Because what I did was this board connects to your Raspberry Pi via USB, and then on this side you bring your 24 volts in. Yeah, wiring at 2 a.m. is never a good idea. And luckily, I wired this into mains voltage. These are 20 gauge wires, which apparently were good for mains voltage because nothing obvious on this board popped. Like I said, it will not flash anymore. Something let loose on this board. But the its sister, which maybe it is in there because I keep its sister. Yes, I do have it. Give me 1 second here. Actually, is this the one that I popped, or is this a screw spare? This might actually be, well, I don't know. I may have finally gotten rid of the SB2209 that I blew. Nope, that's it. So SB2209, this is the fuse. And if I can get it to focus, which might not, that fuse housing is singed, and there's actually pieces of the fuse housing that have detached. This is a ceramic fuse, but that fuse took the brunt of 120 or 110 volts over what should be a 24 volt connection. So yeah, yeah, when you're sitting there and all of a sudden you let out the blue pixie smoke, it's never a good feeling. And we got an ad break going on, but yeah, it was one of those things that I should not have been working at that point. It was 2 a.m. and I was continuing to try and push to get the wiring done for a build, and it bit me because I had a lapse. I did not double check my work, and things went pop in a spectacular way. So just be careful. My suggestion is there's nothing wrong with working and doing wiring that late. And that was after a full day. I was continuing post stream. Just be aware, never apply power. Okay? Go get some sleep. Come back the next day, well rested. Review everything you did that night. Look through it, trace all the wires, and make sure that you didn't do the gaffe that I did, which was instead of plugging 24 volt supply into that UTC, I plugged in the mains and sent 120 volts down a board that was only expecting and rated for. Yeah, never work on electricity late, and that's why we say you're working with mains voltage when you're dealing with these power supplies and you're dealing with the line in, line out. At least with the power bricks, everything you're messing with is DC, right? So I have so case in point, this is kind of the standard barrel connector that'll come, and the input at this side is your 24 volts, 12 volts, whatever your power brick's providing. These screw down terminals coming out the back that are going to go directly to your board or some other Wagos or something distribution is DC current. It's going to hurt you, but it won't kill you. 110 can kill you, right? So just be cognizant of that. Make sure that you're using the right connector, that they're rated appropriately. And my suggestion for your Rook is probably not to use one of these. Use the actual pass-through connectors that you have a locking screw to lock in, sandwich and lock in, and then either use crimp connectors like you would on a power switch, or direct solder to the back. Gives you a better connection anyhow. Yes, so the printer is the Rook is going to take either 12 volt or 24 volt. We normally supply 24 volt because it is it's a better option overall. Sorry, I'm trying to think where I think my wire's underneath here, underneath all the Rook parts. Yep, it is. This wire box. Okay, so we're going to need blue and we're going to need black. So this would be your standard like LRS size power supply. This takes up, this is a 350, but even the 200 takes up like the entire underneath of the Rook. And this is kind of what I was talking about. If you're using the crimp style connectors, the spade style connectors, one, make sure you've got the insulating jackets and they're always down there, or have some other type of cover for it. And then two, if you decide to use these on like those little barrel jacks, which you can, make sure they're the right size and they're not oversized. So does the printer only need 24 volts? So theoretically, does that mean if I plug two into one outlet, I will blow a fuse? Are you talking about running two printers off of a single power brick? I would not do that. The power bricks that we're going to get are going to be like 200 words. Are going to be like 200 watts, and that's going to be perfect for doing these little Rook printers. The if you're talking about putting two power bricks into the same wall outlet, yeah, no problem. That you're not going to draw enough to pop a single. So okay, so yeah, you'll be fine. All of my printers, so the printers that you saw me with at Rocky Mountain Rep Fest, so we had the Annex Engineering K3, the Micron, and the Salad Fork. All three were running during the entire show. They were all plugged into the same surge protector into a single outlet. Right? Everything you see behind me on the wall right here, there is a single circuit for this room right now. So my whole streaming setup, all of the printers that are turned on back here. Now, granted, I'm only printing with the Bamboo right now, but I can print with 2 or 3 with no real issue, depending on which computers, because I've got like 3 or 4 different computers in here. So every once in a while, I'll forget while I've got my my MacBook, my work MacBook up. This is still running in the background, idling, which it's Windows, so understandably, it's not a Raspberry Pi. We've got all of these that have Raspberry Pis running in them, and if I fire up like 3 at the same time, and here's the key. Most of my beds are mains powered. So the issue is if I get 3 printers or 4 printers and they happen to hit the juice to the bed at the same time, I'm probably going to pop the circuit and have to go downstairs and reset. That's because the mains voltage heated bed is what's going to be the largest consumer, unless you're going to be like me and start running Staccato HE50, which takes 2 super volcano size 100-watt heaters. That may draw more than the bed. But yeah, it's the total number of amps, because most of your home circuits are rated for 15 or 20 amp. And if they're at 15 amp, they're running 16.2 or maybe 14.2, whatever. The cabling's rated to that amperage. And in my case, the circuit that feeds this room also feeds the garage and the lighting in the laundry room right beneath. So that it all depends on what's on the circuit and what's pulling at any given time, and knowing that if you're just pulsing to keep the heat on a bed, you're going to be okay. It's when you're starting from a dead stop and trying to bring in a 6mm 300 by 300 bed up to 110C. You know, it's that point when it's going at 100% trying to heat it. Yeah. So my plan, and I still need to get an electrician out here because I want them right outside this wall. So I've got the sloping. There's a gap that's probably that wide between this wall and the exterior wall of my house. And I'm right up above the garage, and my power panel is almost like right behind where the bamboo is downstairs in the garage. So I'm going to have them run wires up of the appropriate gauge and drop me right next to the existing outlets. I want them to drop me 2 20-amp circuits out here, or 2 sets of outlets. It might be a single 20-amp circuit, but that way I can take all of my printers and put them on a 20-amp circuit and get them off the main room circuit. So I shouldn't have any more power outages. I'm also going to have them run a 20-amp circuit into the garage. That's a dedicated 20-amp, because I've got a 110-volt welder that was given to me. So I've got that, and I've got the Milo that's going to be coming, and those are going to be down in the garage. So once again, I want to get those on a dedicated circuit, because if I plug it in and start trying to weld something, or if I'm running Milo, it's on the same circuit as this room. So I'm probably going to pop that circuit quite often. So there we go. Now that we've talked about electrical stuff, yes. So, and here's the thing. Not necessarily required on your hot end, but um on your heated beds, especially when they're like pretty much all the ones back here that are mains heated, meaning you're going through an SSR and you're sending 110 volts to the bed, okay? There is a setting. Let me just jump into one of my random printers over. Oh, Iron Dragon might actually be turned off at the moment. It is. Why is she? It might be turned off because I think we took a power hit last night. Oh, which side? That side. Yeah. So she's gonna come up. Meanwhile, we'll jump over to Bay Dragon. There is a setting that you can put in Clipper for your beds that are 110 voltage. It'll be under your printer config file. Go down to your bed heater settings. So heater bed. It is this setting right here where you set your PWM underscore cycle underscore time. What you're doing here is you're setting it to 0.0166. This works for us in the US where our power is 110 60 hertz. If you're in the UK or elsewhere where you're running 230 at 50 hertz, it would be a slightly different number. But what this does is it sets the pulse width modulation cycle time to 60 hertz. Because if you do not do that and you're using LED lighting like I have in this room, my LED lights up here, the LED light up here will flicker and it's based on and it only does it when the beds are heating. Once the bed, if the bed has to cycle on and off, you'll get a little bit more of a flicker. But yeah, this is a very critical setting in your printer to keep from having stuff blink around the house. If you're using incandescent bulbs, I don't think it matters so much, but it will, the sensitivity in your LEDs, major. Okay. The other thing I will tell you is you may be apt to hit that little button down there that says update all. Don't do it. Especially if you have CAN bus. Because chances are, as soon as you update the clipper, like doing this update to clipper from 69 to 191, I will most likely wind up having to reflash my controller board and the CAN bus board. Public service announcement for today. So, and with that, I've got a length of black and blue wire, and this is going to match the wiring that we're using for Blackbox. So I'm just going to go with whatever length I have currently sitting here. It was, I don't know, some other run or it was the dregs of a roll. So we're just going to use this. And the plan is to solder to our switch and I can never remember which side, which pin. But I do know that we go on the opposite don't do the center pin, we're going to go on the end. And I have to see if we got a wire. How's everybody doing today? Anybody got any big plans for today? Weekend? I'm going to jump up here real quickly and see if I can get the wiring diagram. I believe there is a wiring diagram. I just want I just need to get things soldered in the right direction. That's out here. Normally it doesn't matter. I don't think it matters with rep wrap either. I know with like clipper, if it's reversed, you can just go in and put in a check mark or something else to reverse the trigger, how it triggers. Electron. Is there not a wire? Sorry, folks, bear with me. No physical. This component goes. Shows the physical mounting of the switch, but it doesn't show the actual wiring of this. So I guess we'll wire it up and we'll give it a shot. And if we have to redo it later on, I pop it back off and resolder, no big deal. You gotta go drum line. Oh, that's cool. I didn't know you played the drums. Have fun, tugboat. Probably pop in and out every once in a while. Okay, sounds good. Doing chores for Old Know Me? Gotcha. Yeah, I get you there, Rodney Mac. So it rained yesterday, which impacted my going out and doing some of the cutting. I worked on getting everything tapped and ready to go, and after it stopped raining, I walked out and went to the shed to do the cutting, and then came back in and spent the rest of the time in the garage doing the drilling, tapping, all that for the frames for the Rook. Looks like our rain is going to be later tonight and tomorrow. Hopefully we're good. Still making granite shells for printer stands using an old lab tabletops. That's awesome. That's cool, Timor. Okay, so once again, I know it's the two ends. I'm just going to go ahead and do the black wire on the end farthest from the trigger. So this side is going to get the black. This side will get the blue, because this should be the ground, then this should be like normally open or normally closed. So that would be the signaling. So I'm going to do black on this side, blue over on this stud. So let's get our soldering stuff over here. We've got our solder. We've got our OmniFixo. Really, really, really love my OmniFixos, by the way. And we'll need our soldering iron. And the nice thing about this is I use the same power brick for both of my PS101s because I'm never using them at the same time. So this one is for soldering, and then the other one stays in the self press for doing no, that was right. The other one stays in the stealth press for doing heat set. Let that warm up. I need to go ahead and get an end stripped on these. You don't have to strip a lot. We're not going to be doing anything crazy as far as these wires go. We're just going to strip a little bit off of each side. And I definitely need to do this type of fiddly stuff before all of this coffee kicks. Got the black rifle. Like I said, we've got our backup coffee, and Mrs. Dragon just popped in with some Dunkins. So, oof. Somebody can't count to 10. But that's okay. So all we're going to do is get a little bit of solder on our tip to pin the tip lightly, knock it off. And then we're just going to pin the ends of our thing here, which then we'll need to do the same thing to tin the ends of these wires. And then we're just going to apply a little bit of heat into both pieces. Melt the solder that's on both of them to join them together. Just like that. Got a quick solder. And I didn't bring you guys over closer, did I? Sorry about that. Always make sure that the material that you're trying to solder, you apply the heat to that first. um, because that will help it wick in the solder. We're going to talk about a little PSA, do as I say, not as I do. You should have a fume extractor. Okay, so we've got our 2 wires. Now, because I knew that there wasn't an end on the other side here, I'm good to go with grabbing a little bit of heat shrink and pulling it back the full length. Doesn't need to be a big long piece of heat shrink. I suggest getting a heat shrink kit off of Amazon, or where you find it on clearance through like KB3D. Go ahead and get one. This is all different sizes. Never know when you're going to need some, and it's always good to have some on hand. As well as various types of JST connectors, doing printer builds. So, and the correct way of doing this would be to use a heat gun. You'll see people that will use a lighter. You'll see people that'll use the soldering iron itself. Big thing here is you just need to apply some heat to get your stuff to shrink. I'm just going to apply a little bit of heat with my iron because it's already hot. And I'm not using the tip when I do this. I'm using the part of the barrel, not the actual tip, because I don't want to foul that tip. So I'm using this area of the barrel right here versus the tip when I do things. And we're done. So we'll go ahead and get rid of the power there. And the rest of the wiring that we have to do today should all be just actual physical crimping and connectors. And there's not that many that we have left. There's, I think, 1 or 2 on the tool head. And then there's the 4 wires for the cooling pump and fan. So don't really have a lot left to do. Have the Omnifixo, scoot it off to the side. Move this back over here because I know me. I will burn myself if I don't get it out of the way. And like I said, these are extra long, no big deal. We're going to cut it to the length that we need. We'll add the, we'll crimp the connectors on. Oh yeah, we've got extra. So this one is going to be, I'll say, fully leaded. And then this one that's sitting in my Yeti mug, fully sealed with the lid shut, will be regular, and it's half and half. Half regular, half unleaded. So we're going to get this installed again. Now, we may wind up having to bend these wires around. So that's the other thing that we need to be a little careful of. That's why these are very short nubs. So we just need to make sure that we can get a good movement on the need to. We'll detach them and maybe come in from the side if we need to. I don't think we do. We'll see. Move the coffee over there because we need to put the printer back up here, and I'm trying to make sure that I have the most room available up here with no obstructions because, like I said, she getting heavy. Just had a thought, but yeah, I think we'll still be good. So make sure that you get a good grip on her. Like I said, she's getting heavy. She's got a lot of mass down at the bottom. So make sure you get her, you've got a good grip. You're not gripping the belt. Oh, yeah. Oh. Whew. And watch out for the panel do. This is probably pulling off on installing the panel do would have been a darn good idea because once again, heavy, chunky, and this it kind of gets in the way. So just be careful. And we're starting off at the tool head again. And we need to mount our end stop back in position. You see it, there's a good way of showing that off. And there might not be. I'm going to turn her around, get a side view here. Because that Z end stop mounts right here. So not going to be an easy thing to show. Trying to figure out the best way of running the wire. Plunger goes towards the front, towards the tools, stocked along. Wonder if I can bring the other camera over so you kind of bottom up view. See. Sort of getting closer. So where we're going to be installing this, right where these two heat set inserts are at, that's where the end stop. Like I said, bringing your wires back down and around is going to be a little tight, just a little tight. You have a question, how long will it take you to finish this awesome printer? So Killer Dragon, this has been a long build. This is not a, I'll say a faint at heart printer. This is very complex. We are getting closer. Right now we're finishing up some little doodads and we're getting closer and closer. So we need this, we need to crimp to connect, well, one more connector here, do a little wire management. Each one of our tool heads are going to get connected and we need to do some additional plumbing on the left side of the printer and then we'll be ready to do commissioning. So we're really close. Don't need to do a ground wire. Yeah, we're really close. Just a couple more things left to do, and we'll be ready to actually fire this up and start doing some software. So this, like I said, this particular build has been one of the most challenging. This is not a first printer by any means. So once again, the plunger of the end stop needs to go on that side, connected in through the end start with. This is where I've got to figure out wire bend. Should work. Now those are in. This wire, we're going to bring around to the back. It looks like there is a bit of a little cable trough right there. Bring this wire in. And then we're going to bring it up and along the side of our print head. Just trying to gauge overall length right now. I'm going to give this a cut. And then we can strip and do the connectors there. This wire away. But yeah, Killer Dragon. This is taking a bit. We also have the VZBot build that we were going over earlier in the stream. That one is going well. That's very similar to our Annex Engineering K3 and how it is built and operate as far as the whole 24 volt 48 volt for the drivers and things. Now in that printer we've got, see if I can maybe there we go. So I'm going to be working right here with these two wires. I'm going to go ahead and get them stripped and get the we're using microfit 3 connectors. So I'll get the right microfit 3 connector, on there, and then we will join those two together and add another zip tie, and we'll be done that part. And then we'll get started over on this side of the printer with the rest of our water line. Doing male housing with female pin. Grab a couple of pins. But Poondog, or not Poondog, my bad. Killer Dragon, this particular printer will be done here shortly because it's going to Midwest Rep Rap Festival in Goshen, Indiana. So it will be, that's the intent, is to get it done to make it to that show. And even if it's not, I'll say, fully configured, fully printing by the show, will be close enough. And the good thing is KB3D is going to be at the show as well. I will not be the only black box there. KB3D will have theirs. I'll have mine. I believe Hoyty may have his. So we'll have 2 or 3 at that show. And that is going to be the intent, is to have this ready for Midwest. And if I still have some things that need to get done or I'm not perfectly tuned in, I will have support there by the people that are putting out the kits. You know what, Timor, I have literally thought about that for getting some of these up on the table easier. I do have a rolling cart, but I have seriously thought about going and getting one of those hydraulic lift tables for specifically doing this. And in fact, they keep telling me like, "Oh, come back, come back. We haven't seen you in a while." And they keep sending me the 25% off an item without any restrictions. So yeah, I might have to go and pick one of those up soon. Okay, and once again, this is a 2-pin male, or yeah, 2-pin male connector going into the female connector. And what I like to do is just physically put the connector in so I know which side which wire is going to go in. One's there. Black, red, red. Connected. I'm going to bring this underneath the kind of above above the motor underneath the water connections, just to keep them out of the way. Wire I did make a little bit longer than it probably needed to be, but I'm going to put a zip tie right there to keep these out of the way. Out of the way. Yeah, the one that's or the part that's going to be really fun, uh, Timor, is getting this downstairs because I am upstairs. So that's going to be the fun part, is getting all of this downstairs um, when the time comes to leave and head out to the show. I believe there's wire management right there. Let me see. Got holes. I just can't remember if that's wire management holes or if those were set screws. Those are set screws. Wire management. Okay. Be good there. See why we wouldn't be. I don't want to over constrain things, but I don't want it to be kind of ugly and flopping around either, where it can get caught in things. Okay, that part's done. One more thing off the checklist. Um, we need to finish working on the which we need to finish working on the water pump and on our um, tool heads. So hard. Tool heads. I am going to swap some tool heads around, and I will be doing some stuff off stream. I think I finally decided. So in the manual, there was a discrepancy, since been fixed, but one manual called toolhead 1 or 0. So 1, 2, 3, 4, 5. And then the wiring guide shows it 0, 1, or yeah, 0, 1, 2, 3, 4, or 1, 2. So this one is wired correctly. These two are swapped, and then the two ends are swapped. So the option is I could take this side panel off and redo all the wiring. for the 4 wires that come into each one of these. Or I could change parameters in the configs. What I haven't looked at is whether or not the parameters in the config would be like a one location fix or we've got to do this in multiple places. So that's something that we need to look at. So one of the other things that we need to do here, so each one of these I did mark as like H4 and T4. So that's why that's a decision that needs to be made before I make the final connections here, because I would have to take this panel back off and do the, pop these out and swap them around. So yeah, I've been chatting with KB3D Chris on it. As to, and he was the one that suggested, well, just swap the wires around. Or not the wires. He said swap the config. But then my fear is my config is different than the standard. And I hate that, number one, because you got to remember that if you ever grab a config from somebody else, you've got to kind of remember that. And, I'm not getting any younger. And yeah, so Timor, this is a 1-story with a bonus room above the garage. It just so happens that that bonus room is my office and my streaming studio. So unfortunately, that kind of puts me in the out. And getting the 350 Trident down was a feat in itself. This thing is heavy, and I don't know if there's going to be an easy way of getting it down without having like Evil Diesel here and doing a 2-man thing. In which case, it'll go downstairs, and then it may live downstairs in perpetuity. Because yeah, she a chunky girl. She is a chunky girl. Okay, so the other thing we need to do, like I said, is we've got our water pump, which has a 4-wire Molex plug. We've got 2 wires that aren't being used. So on this pump, and I'm not sure it's actually secured in there. I think it's on this side. There's a screen on one of these sides. There's a screen that we're not seeing because of the way it's mounted here. So that's what 2 of these wires would be for. Not going to use that. So this is power and ground. And then we've got the fan that's going to be cooling the water coming through the radiator that's right behind the fan. So we're going to take this end off. We're going to join these together in the same hoofed up. And then the connector that it connects to is right underneath here. So that's going to be a tight fit. Doable. It will fit. But the thing is this wire is not going to be long enough in any way, shape, or form with the way it's routed. Because this wire to this connector right here is just like, it's going to be, call it taunt, to get it down there and plugged in. So I'm not sure. Oh, maybe it goes in that way. No, it might do it. I keep bringing it to the side. If I bring them straight back, it should, yeah, it'll do it that way. So what I need to do is figure out the right pinout order for these. Because it definitely says to make sure you get it in the right order on the wiring diagram for not, I keep saying it, the diagram. There is no wire routing diagram on this printer. Diagram that we have is for like point to point and mapping of the plugs itself. So that being said, I'm just sitting here knowing that the best thing that I really should do is take this panel off and redo these wires. Just a choice. But right is better than lazy, right? Something like that. Doing it right is better, especially on a $3,000 printer. The last thing we want to do is get a config wrong or tell it, hey, go grab this tool. It grabs the wrong tool. And now we have an issue. So best to undo our panel. Should be able to just lift it off at this point still. Okay. So once again, the wires in question, and the reason I need to take that panel off, all of the wires in question are right in here on these. So there's a distribution board on each one. So there's a 4-wire that comes in from the board, and then there's the 4-wire that comes out from this board and goes to the tool head. So each one of those are labeled. Really, the umbilical going to the tool head, it doesn't really matter. I could change the label on them easy enough. It's really this end, getting them routed to the right places. I could just change the ends on the board and, I don't know, throw a post-it note that the names are all backwards. Hey, zombie. The zombie. You've done enough builds as well. So I'm following the directions. At one point in one of the manuals, it showed tool 0 over here, tool 4 over here. The wiring guide, tool 0 is here, tool 5's over, or 4 is over here. So I wired it up 0, 1, 2, 3, 4 instead of 0, 1, 2, 3. Would you go and redo all your wiring? Would you go and redo all your wiring or just change the config? Yeah, so relabel. I did heat shrink labels. To quote unquote relabel, I would have to depen and redo all the. The point is there's no easy way I could, because the chances of me getting to this back are slim to none. And actually, does it just say? Yeah, sticky notes, my best bet. So I think the best thing to do is to swap out the umbilicals that I need to. And then make the correct changes at the board and not worry about the ones back here. That way the board config's the same, and this, the wiring to the tool head looks to be appropriate. It's the labeling at the connections back here that's going to be off, but everything should fit underneath the tool head board then. Because it really, what it comes down to is how much wiring do I have to pull out and how convoluted is it going to be, because the wiring comes down here, goes up one side, goes under, comes back the other side, and then goes over. So it's a little convoluted and messy. But I will say one of the things I'm going to do is pop the bed off. Because getting the bed off decreases the weight a little bit and also gets this out of the way so I have better access to the underlying electronic stuff. Makes it easier to work down here. I'm just going to do it. Do the right thing. Thought, nope, that's completely undone. Okay, good. So we're just going to do the right thing. Okay, that one comes off. Major pain. I just really no. Yeah, you see enough of my builds to know I'm just going to say screw it and do it the right way. My biggest fear is the amount of slack that I'm going to have down here in the various tool pieces. or in the wiring. Whether or not I can get that slack pulled out along the way or not. Because two of them need to be pulled further down through, and then two of them will need to be pulled further this way. And that's where I was saying it might just be easier to pull and play with the cable trough. Yeah, and the thing is like this side, no big deal. It just says FDM tool dock. It's this side which is calling out tool 1, heater 1, or thermistor 1, and so that's the part that sucks. And once again, 3 is 3. Doesn't matter which order it goes. 3 is 3. So we don't need to undo that one. Unless we have to make it easier to pull and route everything. All right, thanks for the alert, Timur. And this goes to the fact of we noticed a discrepancy in the manual. That manual has been fixed, so Steve Builds and Zombie, when the time comes, will have both of their wiring guides will be correct. Hopefully at some point they're actually able to get linear wiring harnesses and they don't have to build their own harness. I will be a little jealous over that, just saying. The 3 is going to stay the same, and all these others are going to need to be either pushed or pulled or what have you. Best idea was to run it like that. Yes, I know that would be my dumbass. Okay, so open the cable chains up, we'll open the troughs up, and I think we're just going to have to, it's probably going to be easier just to come in and pull most of the wiring out of this cable. I'm going to call it a cable ladder versus a trough or a cable chain because it's really just a straight up and down. And we're basically going to just redo these wires. No biggie. We got plenty of coffee. We'll probably have to take a bio break, but we got plenty of coffee. And then once we get this wiring stuff sorted out, we'll be able to work on the umbilicals, getting those done up, which is why I need to go down and grab the vise, because we're going to have to work the spring steel wire and get it into a straight form factor to make our life easier. So this is the set of umbilical wires that comes up to the tool head. So we're just going to leave that kind of dangling out of the way. Hopefully. The rest of our wires we're going to have to pull out as much as we need to, knowing that it's correct in the on the board. It's more of getting stuff pulled through and the slack pulled out, because I wound up having to like do bends in some of these wires because they're technically in the wrong spot. So we'll have to work on getting that stuff squared away. It's probably going to be easier to pull these out anyhow, hopefully, and reroute them as needed. Definitely not do it this dumb time. This dumbass way being feeding connectors through an end loop. Five cable pulled down and out of the way. And not going to be an easy way of doing this. Got so much flipping wire. And Zombie can tell you about this. This is about like, you know, hey, we're doing a beta build. There may be instructions, there may not be instructions. There may be some intuitive thinking that needs to occur, right? So the intuitive thinking that I'm having to deal with right now is my cables are pulled through a trough and not readily it's not readily easy for me to pull these back out at the top end here. So probably what I'm going to wind up having to do, give myself some slack, hopefully work it down here at this end, which is going to be sad because it's just going to be painful. You can possibly tell, got a bunch of cables that are in different order going into and out of this trough. And trying to decipher what is which bundle is going to be the fun. Because it's all loose wiring at this, not individually wires. least get one of the back down and through here. Room to hope. Basically, the plan is going to be to back these wires out, maybe just take them out completely, then reroute, just reroute them all again. It'll be easy, and I can detangle them in the process. No easy way. And this works out better anyhow because I did some, we'll say, creative wire routing down here for some of these. So probably not a bad idea. I'll be able to get these wire runs a little nicer. Something. All right. Yep. This is going to be fun. Yeah, this is going to be prove to be fun. We've got wires going through wires around wires. Which once again is part of the reason why I think it was wise to go ahead and pull all of these out and reroute them. Is so that we can get everything a little less tangled up in here. I'll let you know if that happens. Now they say that you should not put zip ties in cable chains. However, these are not moving cable chains. These are a cable trough. So there may not be, it may not be bad for me to throw a few zip ties in. To try and get things properly squared away. And I swear these cables were oh, and these things get so intermixed. Um, Good question. Good question. We're going to work with we're going to take the panel do off because it's just 2 screws and it's going to give us access to this side to work a little so that we can undo the wires from the board. And of course, dropped through. Then we'll do is back off, that back on once we get the wires sorted out. Because I believe what's going to be easiest is to take the wires off the board and then start tracing them back, because part of what we've got is we've got one end that is or whatchamacallit. We got one end that is going into 4 wires, and then the other end is 2-pin pigtails. So we've got wires that are able to get intermixed, interspersed, whatever you want to call it. Point is they can get tangled up. That's what we need. Try and getting things up more than they already are. Okay. There's one set. There's a second set. Set. We're set. Still got. Those were the 3 that went to the one board. Now I need to get the ones that go to the other board. So these are the heaters. And the thermistors here. I hope so. And because of my superb wire routing, where my issues have been is bringing things up and popping it up into the panel, wire truck. Ay, 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 ay. All else fails, pull all the wires. I hate to say it like that, but yeah, part of my issue is how I have routed these up and through and around and trying to be all cool and sneaky with my wiring, and it really wasn't. And I make So I was kind of sort of kidding. Now I'm kind of sort of not. All right. Sorry about this, folks. This is not what I intended to do today, but this might be the best and easiest solution to this overall problem of wiring. And as I redo this wiring, I will need to do some zip ties here and there throughout it to make it a little less prone to wrapping around itself. Got 3 pins going into this connector. I've got this whole set of wires that's going right between it. Yeesh. Okay. Definitely needs some wire detanglement. Hopefully the end result of at least this part will be, I'm going to do a few more zip ties to keep this kind of bundled up as it goes through. Once again, this is non-moving, so we don't have to worry about things moving within the cable chain itself. So we can go through and use zip ties here. And if you were doing this with a lineal kit, you would have a nice, you would have, and I do have some cable braiding. I just had not been using it, thinking, well, why would I? Cable trough should be fine. Why would I braid things if I'm going to put it in cable trough? But I am going to go through and, at least for a good portion of this, get this stuff put together. Don't want to necessarily put these together, but I do want all of this stuff that is going to go up, down, and around and into the controller boards together, so that if anything, they're tingled on itself. I shouldn't have to go and break an individual, or not break an individual. I shouldn't have to go in and fix these. I don't think any of these are going to fail in any significant way. that will make life a little bit easier. And when we go back to do the other ones, we will do the same thing. Because all the wires going up to the FDM toolhead are, once again, static. They're not moving. They're not changing. It's 2 heater wires, 2 thermistor wires. I shouldn't be changing that. If anything, I'm changing the toolhead itself. So all the wiring up to the toolhead should be the same, right? All the wire up to the umbilical. Part that moves from here forward. So if anything's going to break, it's going to be in that part, not this part. It almost would be nice if there was a breakout board somewhere over here, so that you'd have basically home runs to the breakout board. And well, this stuff coming down and around, since this cable tie. Maybe not. I think we'll leave these 3. This is a bundle, and all my FDM tools. Finish finding and fishing these wires. All right, here's another one. What I can now is dock 0. Dock 4. One down here. Rewiring. Just did 4. This 3. 2. All we need is dock 1. Is the last one that we've been rewired. So we've only undone like, I don't know, 2/3 of our wiring. Not like going back in time. So what do we have here? We have 0. 1. Oh, no worries, Killer Dragon. Trust me, we get it here. Knife gets in the way. Two stays as two. Need three. And then finally we'll need tool. Okay. What I'm trying to do is just layer these in the trough. There is a wire trough there. Um, that way. And so there's these wire troughs, but there's no call it there's no like wire tie channels for them. So we're just trying to lay them in the trough. I think what I want to do is layer wise. We're going to get these laid in first. And this is stuff that's coming from like our Z motor and stuff like that. We have to do a little wire man right there with a little bit of 40/40 whatchamacallit. Do some 40/40 um wire. We will do some 40/40 kind of like the trough stuff that fills in the trough in your extrusion. We can use some of that to hold our wires in place. Meanwhile, I'm just bundling up our FDM cables, all the power and the thermistor wires going to toolhead boards. Same thing as we did before. They're pretty much going to all go to the same place, so we're just getting them somewhat bundled together to make it easier to move them around. These aren't like wicked tight zip ties, so if I need to, I can slide them fore or aft to get them around bends. We'll have these. I want to stretch these, so I need to kind of leave myself some operating slack in the wires. Add these into the trough. We'll need these come over as well. Minus an off gauge. Going through and doing this, hopefully, means our wires are a little better managed. I say that, and then I wire here this. Once again, I'm calling this a cable ladder, not a cable chain, because it's really not what we're typically used to seeing as a cable chain where things are moving around. What we're seeing here is more or less wires that are just being routed for, make pretty routing. This is make pretty. Nicely. Okay, so there's the first cable bundle going down and around. Here goes the second. Hey, Zombie, thank you for the lurk. Yes, coffee time. We've got plenty of the dark blood of life. Sorry, I've been head down again. It happens when we get to wiring. I tend to get a little bit more head down. I do not mean to be. I just know that that's how I tend to get the other nice thing by adding these cable ties in essence, we're identifying the different bundles of this is the tool head bundle, this is the um, this is the tool head, this is the actual X-Gantry bundle, this is the a little bit of a miscellaneous bundle back there. We catch on. Did we snag on? Wires got away from me and wanted to play their own routing game. And this is where also, like I said, doing a little bit of sleeving probably would not be a bad idea in order to get stuff routed very cleanly. Line. Have these in. Okay. So we've got everything kind of semi-routed up and down. Everything at the front just seems to do its own thing. And now we're going to put a cap on it. Try and hold things in. My issue is I'm kind of getting pushed up and out a little bit by my underlying power wires, which I think my power wires I may have cut just ever so slightly short. Now having No, there we go. There we go. There are a few other wires that'll need to go in here, but for now, I just want to keep this stuff from continuing to pop out on me. When I say that, I mean there's got this wire that'll need to go in there that goes up to the front, which is for the water cooling. And then our SSR activation wire, which will pop up from underneath. This one goes up underneath. But for now, that gets us kind of where we're at. We'll need bundle one. Bundle one is going to be pushed down and go under and around. Okay. What we're trying to do here is we've got wires that need to come up and underneath and around the that central the central area there. Basically, we're just looping them up and under this 1020. Case of getting the wire bundle. Here we have all of the wire. Pull it all over. Neatly and cleanly. Okay. And now it'd just be a matter of where do these get run to now that we have them over here. Somehow I've once again gotten wires twisted amongst each other, but that's so we've got 6HC out B and 6HC driver 1. There, this will also go down here. I think driver 1 is 012. I have plenty of wire to get around to where we need to go on this one. 012. This wire could probably be shortened some. Next up, we've got our red and black bundle, which is all of our thermistor and so forth wires. And I'm probably going to take some of these others out. because they should be routed over the ones I'm getting ready to bring in. Motor, which, like I said, that motor is kind of long. This output wire that came down with the motor, 6HC output 8. So I'm going to need to get my board diagrams back up here so I can figure out which goes where. And I'm probably going to turn the printer around a bit. Thank you guys for hanging out with me today and dealing with me as I deal with this. My intent was really not to completely tear this apart and redo the wiring on it, but the more I think about it, the more I think this was the better idea. Oh. That one, I mean, it wasn't bad either, but okay. So we got it turned around so I can work on the two boards here. Let's see. Back again, just had to take care of things. Hey, Hobby Main, welcome in. Benchy, thanks for the drop. Hey, Warwick B, thank you for the follow. So Warwick, we are in the process. We had it all wired up, and my FDM tools up here, my 5 tools, I had wired it with tool 0 being all the way at the left or towards the front of the printer, and tool 0 by I was going to say by definition, but by all the wiring should have been down here. So the wires on the board were right. The wiring at this end was wrong. So we've pulled all the umbilicals off and got those routed to the correct slot now. We got we wound up having to pull all the wires out, and we're joining them together using cable ties. This is a non-moving chain. Everything under here is non-moving, so putting them in cable ties just makes the bundles a little bit easier to work with. But it did mean that we also disconnected a bunch of stuff on our board. So now that's what I'm trying to do, is come in here, make the wiring pretty again, and get things wired back up in the correct spot. So what I'm going to need to do is bring up the Do-It website so that I can pull up the different boards that I'm going to need. So we have our main board is a Do-It 6HC. And then we've got an expansion board, which is the Do-It 3 expansion board, which is the 3HC. Just need to get the documentation. That will have our, we know that everything's wired right. We just need to actually get it plugged in. We just need to know which pin goes where. That. Okay, so this, and let me bring up, no, it's probably going to be real small down here on the side. Apologize for that, but that's kind of how we're going to need to work. And actually, let me grab the other camera because I can get that closer to where I'm working. Hopefully. Yes, that camera is on. And what we're going to do is we're just going to bring one piece of bundle in at a time. So we've got this motor that goes to motor 1. As you can see, there's a bit of excess there. And so I'm going to have to reroute that. I do kind of want to get that put. Hey, look, let's just undo everything. Try and redo our wiring from scratch. Because why not? Okay, so we've got our power that comes from, we got power that comes to the board, and then we're going to tag off of that and bring power over to our 3HC. So we're just going to kind of tuck that in. We'll have X-HC temp 3. So our temps, this quadrant here, temp 3 is the last one. This is 3. That tucked in there. This is our motor. Once again, our motor comes up and it's way longer than me. Definitely wrap this in some. I intended these to run. This one is way long. This is the motor, I think. I mean, we could potentially cut this and make it shorter. 6HC driver 1. Yeah, that's the right spot. what I like to do is bring these straight across, route them into the cable trough, and then right there we can make up some of the excess, putting it into this side trough there, trying to cover some things up. This here goes to I05. Zero, 1, 2, 3. The 5-volt external, which comes up here. Disconnect. Two. 8. Oh. One, two. What I'm trying to do is just keep my wiring neat so it just shoots straight back. And it's easy to still see everything that's on the board, still get around everything that's on the board. Later, so that was first bundle. Now second bundle is all of our heater and thermistor wires. And once again, this bundle needs to go down and under, back up, which is easier said. Out of the way. I think it's going to be just easier. Get everything up and under bundle wise, and then we'll come back in. Yeah, so work B, this is a 5-head tool changer design printer. We are just trying to get our wiring done up. Like I said, I'm one of the first people, so I am looking at the build quality, the manual, and providing feedback to KB3D. We have found some issues in some of the documentation already, such as cable lengths, cable routing, um, stuff like that. And one of the biggest issues we found was a discrepancy in the documentation that outlined the tool heads being installed in one direction, and then later on when you do the wiring, and I had to build my wiring loom, and that was the indicator when I had wires that were way too long and other wires that were short, is the fact that the um, the order of the the ordering of the tool heads and the documentation was different in two places. So we've gotten that squared away, and now it's just a matter of trying to get our various bundles and wiring figured out. I think I might have just got a bunch of stuff tangled, which is real easy to do. I was kind of building this, building the wiring harnesses as I went. And there was a couple of wiring harnesses that I just did not have enough wire to do. So I had like 2 or 3 of this done, and then another 1 or 2 of this done. And then it just wound up being oh, we're going to need to redo some wiring to make things neater. What the final end result was. And of course, in the process of flipping wires up, down, around, and everything, always wind up getting wires twisted amongst, such as life, work around. But so far, it's been a fun build. Couple of very minor frustrations, like what we're dealing with right here, but other than that, it hasn't been a hard build. It's just, a little bit of tediousness. You got to concentrate and really pay attention to what you're doing so that you get things routed nicely, um, and keep things organized, because maintenance, as you can tell, if you've got to get into these wires, is going to be such a joy. This one goes to output middle. like I said, so far nothing too crazy. We're just trying to play with our wires, keep things nice and neat as much as possible. Keep things without having a major radius or a bend to them. Now this is where things will be kind of a little more of a pain, but need to detangle this somewhat. We'll have pairs that go to different boards. So we just need to find those pairs and then bring them over one time. So there's output 0, temp 0. These two wires kind of a pair. This is to the first hot end, I believe. Should have matched the output and the temp together. And these go on the 3HC. So these are going to come over to this board. HC output 0 is where do I have this oriented? Drivers over here. So output 0 is the first one over here. Output 0. And this will be temp 0. 0 should be this one right here. These wires will come over. All of a sudden. Out 1. Temp 1. Be another pair of wires. But and temp. One side temp 0. Output. Outputs. Where's our These ones come this way, that one this way. Okay, got big connector. XHC output 2, 6HC. One, one, XHC 10. Okay. These things come over here, so we're going to go with our heaters. it is untangled as much as it's okay. So we've got one on the 3C. We've got 0, 1, 2 output 1. Zero. Two. Long enough. I think this is going to be all that we need. So for now, I'm going to close it up. Just to aid in our cable route. This one goes to 6HCIO2. HCIO2. This one. There. This bundle of wires. And this cluster of driver 3. Driver 4. Got IO3. IO4. IO1. Put 7. Okay. Now just a matter of popping these in. We did before. We're just going to back, drop them into a slot. Take our lacer. Drivers. Away and just back it in there and fold it over itself. So we do have a couple 3 bits of over on the other side. So I'm going to gently turn her around. Okay. So we've got our solid state relay. This needs to come over, and we don't want it to be on our z-axis if we can help it. I think I troughed it and then went up and underneath to where it went. So what I'm going to do is pass this completely under. Where is this going? This is going to 6HC output 3. This comes over here. This is bigger connectors. So through, plug it in. Like I said, I can bring this over, dump it in the cable trough, and go cable trough, and just kind of do one of these numbers. The other piece that we have here is for our fan and our water cooler. This goes to 6HC output 9. This is also going to go up and underneath. Partly because there really is no nice way of running this. Is where it needs to stick out is just kind of over here in the corner. Route it, and then we need to dump it over. Tell that that's output 8. It's going to be right next to it. Going to come to the general vicinity, bring it up this way, down. follows around. It's going to go into this little front slide here. And then this little 4-pin pigtail just needs to get routed up underneath so that we can plug in our fan. Now I've got one other pigtail here, and this goes to the Cat 5. Bring Cat 5 to the back panel there. There is no generic way to route it other than kind of add it in to the trough and push around with all the other wires. Okay. I think we are fully locked, loaded, and wired up again. Was interesting. We can put the bed back on at any point and wire that back up. Ooh, the other thing that we need to do still is we need to still run a ground. Hey, Tugboat, welcome in. Yeah, so we had talked before the 5 tool heads, right? It goes 0, 1, 2, 3, 4. Well, in one of the earlier manuals, it talks about this being tool 0 versus this being tool. So we needed to redo the wiring because I connected all of my cables up as 0, 1, 2, 3, 4 when I wired everything up. But they were reversed. So that led to basically pulling all of the wires that come up to the tool heads out and then zip tying them together for the most part, which allowed me to get them over to this side of the panel. So what we had to do was basically bring them through the cable chain as 3 different bundles. We have the couple of things coming from here, so the lights and the Z motor, that came down, around, and back. Then we had all the FDM tool heads come down, wrap around, and over. And then we've got everything going to the X-Gantry that comes down, goes down, around, and over to the 2 boards. Got everything done there. We just added in the Cat 5 cable to bring the Cat 5 out to here on the panel. We can put the bed back on, but as I said, put the bed back on, the thought hit me of we still need to run a ground all the way back to our Wago. So that's going to dip under, go in our cable trough, around, up through the cable chain, and then to the bed. So that I do not have green wire. I do have, I believe I've got, well, actually, I may have green, or I don't have green, I have orange. It's a ground wire. It probably should be a higher gauge than 24 gauge. So I think I'm going to have to go with silicone wire because I don't have any FEP wire that's that long. And I really want to stay with at least yellow for that wire. So let me grab my other scale of wiring and see what we have as far as 18 gauge. Oh yeah. Oh hell, I actually have green, so we can do 20 gauge green silicone wire. Silicone wire in cable chains is not a good idea. You should be doing FEP, but the only FEP I'm going to have is, I have 20 gauge FEP. Oh well, hell, I've got 20 gauge FEP. We'll use 20 gauge FEP. 20 gauge should be perfectly fine for a ground. The FEP wire is going to take up less space in our cable trough, which is already getting pretty packed, to say the least. And yeah. Ooh, where's my, we're gonna have to try and figure out about how much we need. This is going to be a direct run to the bed. So we're going to want to have a little bit of excess slack because if we ever go to take the bed off, we're going to need to, of course, unscrew the ground at the bed if we're taking the bed off to do maintenance. Just going to undo a whole bunch of this. Up under, go there. Another one or two or three. Fine. You guys know me, I'm good with some extra. Makes life easier. I can I can always buy more wire. So always good to keep some, cut it if you need to. The cable chain. Open the cable chain. At least that. Push it straight down. Okay. That's there. Gonna be our ground. Ground. Extra. Okay. So we need a Wago at this end, or not a Wago, a ferrule at this end for the Wago is here. We are making progress, folks. Making some progress. This is a tiny 20 gauge. Gray one. Guess it helped to strip that wire. We're stripping this for the Wago, so we can strip quite a bit. Get this seated into the Wago. If for whatever reason the wire sticks out past the, or I keep saying Wago. If for any reason the wire sticks out past the ferrule, we can always cut it flush with the end of the ferrule. But the ferrules work perfectly fine. In the Wagos, you could have done 11 millimeters of bare wire. I've just been doing ferrules and proper connectors on everything. So back from Drumline. Oh, auditions. I didn't realize you were auditioning. Yes, we are still doing the wiring, but we're almost done. Almost done. So this, once again, is going to come into our Wago connectors that I have over here for our wiring. We can pull out the rest of our slack. And once again, we're going to come up same way as the rest of our bed wires, but we're going to be connecting to the bed itself. And left-hand side. Left-hand side with a M5 screw. Once again, a little bit of slack, not a huge amount, but a little bit of slack to play with. The rest goes back in our box for another day, next project, whatever. These little wire kits, wherever you get them from, they're really great to have. Also, if you're like on a on a Rook, right, or any other small printer, you'll have you'll need a wire length like this for a motor, and you get a full meter, right? Go ahead and, once you get your final wiring and everything's working, then go back and clean up the wiring. I just did that on my Bugaboo, and for a while, I had literally my controller sits right above or right below where one of the XY motors is. So I needed at most like a 4 or 5 inch long wire, and that's being generous, right? So snip the end, re-terminate for JST to go on the board, and then you've got plenty of wire there that you can use. It's 24 gauge wire. Most of it's coming FEP now, so it's wire that you can use in another project. And that project doesn't have to be a 3D printer. It can be, just about anything you want to do. If you're doing a robotics project, if you're doing a, any other type of project that you're doing. So this side is going to go into a crimped ring terminal. So we just need to pull off a little bit. It doesn't need to be a huge amount. We do need to get our standard crimping, I'll say kit. Again, this is a terminal crimp kit. I got this off of whatchamacallit, darn it, Amazon. And it came with various terminals as well as the ratchet and crimpers. The nice thing is these have different jaws, so you can swap the jaws out for the other jaw types to be able to do other types of connectors. So they're really functional. Now this comes with butt connectors and your port connectors. These are not the ones that came with the kit. I've ordered several of these. Just make sure you get one that has an appropriate size ring terminal. Like I said, we're going to be putting this in with an M5 button head. And I don't think the kit came with that M5. I'll check real fast. Go ahead and put the panel do back on before I forget and lose the wires. We'll figure out that wiring in a little bit. I say lose the wires, I meant lose the screws. Because I will. I'm going to move that and I'm going to knock the screws out and I'll lose the screws. This is the panel do wiring, which goes to 6HCIO0, which will be this first connector here. And as you can tell, we've got plenty of extra cable to go down and around. So now, the real reason I was trying to dig around over here was to see if we had an M5 button head, and if not, then I will have to grab one out of my own stash. Button head. No, no big deal. M5, smallest. You can get away with like a 3 or a 4 or 6. Whatever your smallest M5 button head is will work. A ring terminal works with that. So now what we just need to do is get our tiny wire secured onto this ring terminal. Color coded, so red, blue, green, yellow. We want the blue, which is the middle one. I find it sometimes easier to get the connector lined up and then insert the wire. Then as always, give it a tug, make sure you got a good solid connection. We can loop that over. We're going to take our bed, sit it on the platform there. We need our button head screw. Probably got plenty of, yeah, we got plenty of excess room here. And especially since we're getting that screwed in. Make sure it's a nice, good, solid connection. And we've got enough slack that we can turn this over. Set it in there. And redo our wires. And we can wire. We can wire tie some of this together up underneath. It's not that big of a deal. Need to know. Do this. We go wire. Fuse. Fuse jumps the load wire. The other bed. The thermistor wire. Do at the end. Doesn't really matter in what order. Just make sure that you're jumping your load to another set of Wagos with your God, why are words so hard? Jumper your load wire with the other or with the fuse, and then the other wire of your bed. You'll be perfectly fine. Plenty of room for things. And like I said, we've got probably a little bit of extra there, but I'm fine with letting that dangle down. It's not going to hurt anything. Um, and if it does, I can always cut it shorter and make it a little bit shorter. Hey sis, how's it going? We've been wiring and in some aspects rewiring heavily the printer. Nothing was wrong with the wires other than the order. Sorry, I just grabbed a power snack, aka Dunkin' Munchkin. So the issue we had, Westery, is one aspect of the manual said tool 0 or toolhead 1 was on this side of the printer. That's how I wired everything up. Problem is this is actually tool 0. So an early chapter of the book said this was toolhead 0, this was toolhead 4 or 1 and 5. Later on, it reflects this as toolhead 0, this is toolhead 4. My concern was, in talking with Chris, was he said you don't need to rewire everything, you just need to change the config. Well, my problem is that means every time if somebody makes a new config and I want to use a new config, I've got to remember to make that change. So what we did was we undid the umbilicals, which was really easy to do, and moved those around. Then we undid all of the wires that go from the tool head boards to the actual electronics at the bottom of the printer. That was more painful, and wires were all, twisted, combobulated. So what I, in essence, did was the, whichever motor this is, the X motor, and the lights came down. All of the wires coming from the FDM tool head, I zip tied together and bundled up. And then the wires coming from the X-Gantry, I also bundled up and zip tied together. It's okay to zip tie them because there's nothing moving here, right? This is not moving. It's just static. So we went through and we routed our cables nicely and redid our cables. Then we went through and added our bed back in, adding in our grounding wire that we hadn't done yet. So now the bed's grounded. All of our wiring is in place. Now what we can do is put our left panel back on here, and we can start working on doing the tool heads. That's where initially we started off this morning with me needing to run downstairs and grab my vise, because we're going to need the vise. So let me get this lower camera or the other camera out of the way. I need to bring and put that panel back up there and get it on. And then we'll need to work on, might put the printer down. I don't know, we'll see. We'll make determinations as we go. So remember, when we go to put this panel on, we've got to feed our water tubes in. The one side is going to be relatively easy. Relatively speaking. This side be relatively easy because they're short and straight. And then they're going to make liars out of them. There we go. This other side is going to be a little more difficult because it's going to be a pain in the butt to get my hand in there to move things around. And There's also, they're not necessarily a straight run. One. Now, eventually, those particular water lines over time will get easier to mess with and put in place because um, they'll be, I'll say, quote unquote, broken in some. Um, Whereas the ones over here on the left, or on my left, like I said, are pretty much they what not one size fits all. What am I thinking? They're just pretty straight. They'll be relatively easy. At the first time. And so over time, these will kind of break in and get into that, um, into the shape. So you will notice there are some printed parts here, and they're not in black. They're in blue. They're in PLA. They were in the blue that I actually had loaded up when I tried them out. I tried printing these out in the Priline CF, and that was a no bueno. That did not work out for me very well at all. So I'm drying my PAC or my PCCF again, and we will give it another shot. What am I thinking of? What am I thinking of? I need some parts, and I need, yeah, wire map. We're going to do some more parts. We'll add some parts to hold these in place. We need to work on some more plumbing, and then we'll get back to working on the tool heads. Just because I think trying to finish up this side panel will be kind of cool finally to see all of this in place. We also need to do this little bit of wiring over here to join these two together, and then we can plug it into our fan cable. Just need to make darn sure that I have it all in the right spot. So yeah, it was a solution. It was just a time-consuming solution. It's a good thing that we've got, I've had full 20 ounces of my Black Rifle coffee. This was the Tactisquatch dark roast. Now I'm drinking my Dunkin'. And then I also have 20 ounces of more Black Rifle Company, but this is Freedom Roast and Just Decaf blend, which is medium roast. So this stream, believe it or not, is fueled by Black Rifle Coffee, not sponsored. Dunkin', also not sponsored. But we've got plenty of caffeine and plenty of sugars. If I start bouncing off the walls, you know why. Tell me to eat a cracker or something. Even weekend, bro. Yeah. On-call busy morning started at 5 a.m. Well, that sucks. I didn't start at 5 a.m., but I moseyed downstairs about 12:30. X Slacker. I've had a Celsius. I have 3 printers running. Oh, this. So this one's been running pretty constantly. I don't know what parts we might be printing. Get up, there we go. I don't know what parts we might be printing on. So this is a Raspberry Pi one. This will directly mount to the standoffs on the board, and then the Pi mounts to this. This one is said for one of them's for okay, this one. This one is actually the mounting studs. This one's not in line, so it's not square. This is for a Big True Tech Pi board versus a standard Pi. So I'm down to just printing like the extras for the 2 rooks. I spent all evening yesterday doing the cutting and drilling and deburring and tapping for the 2 frame kits. One will get shipped to one set's going to get shipped over to Tugboat 3D printing. One will be kept here, and I'm going to build on stream, and he's going to or they're going to build alongside me. But 2 full sets. So these are the 200 millimeter rails. These all had to be drilled and tapped on the ends. These are the 210 millimeter uprights, and these all had to have the blind holes cut into them, cut the length, of course. And then I also drilled and tapped the ends on these as well, just because, well, I was on a roll and kept going. And they're I'll say matched sets. That way, if they're slightly off on length, they're all slightly off on length. So won't be that big of a deal. And I showed you guys the 2 deck panels, right? So Tugboat wanted electrolytic deuterium as their color. And KB3D, I'm doing theirs in the atomic filament, or excuse me, not atomic, fusion filament electric pineapple, which is very close to their shade of orange. This is going to be the 2 Rook 2020s that we're going to put together on stream. Well, I'm going to put together this one. They're going to put together this one. And I haven't seen Pez Liz. Is Pez Liz here? Because I've got a few spare bags, and this is what I'm collecting all the parts in while I'm printing them. Keeps all the project stuff together. Don't worry, Westery. I have stabbied plenty of bags. The fusion filament bags the bags are not resealable. And I've got enough Polymaker bags that I can stabby things. And they're poly dryers. By the way, can you tell that the coffee's starting to kick in? So this was our control. This has never had the dryer run. This was a spool of filament taken out and popped in this dry box. It's been there for 2 weeks, down at 15%. So I would say the dry box is sealed and doing its job. And our other filament, which is, yeah, this one. This is nylon. This is our Co-PA blend. This, nylon is very, very hygroscopic. I did run this in the dryer for 24 hours. So I ran it twice as long as it called for. But this has been holding at 15% since I ran it through the dryer. So once again, a filament that is really prone to soak up moisture. And we're still sitting at 15% over 2 weeks. Not bad. I'm really liking the poly dryers. Okay. Now that I've beat around the bush enough, let me close these. Need yet? Need that one. Sorry, folks. I'm trying to find the trying to figure out where I'm at. I need the instructions for the rest of this panel. Let's come back over here. And we're going to get into the water cooling. This is the part that we started doing before. This was getting everything prepped. Was putting our fan onto the radiator down here. Oops. Which there we go. So we did the fan right here, right? Mounting the fan and radiator into the bottom portion. Slid the pump down in here with the connectors for the pump. Got that added on here. Got it mounted from the inside through the acrylic. Did the plumbing initially. Got that plumbing piece mounted right here. This plumbed. This plumbed. Water block and the plumbing for the X-Gantry. May have a bit extra loop there. We'll see. Got our connections routed through here. Just make sure I routed them to the right side. And they are routed to the right side. This is the part that we needed. So I needed a couple of pieces. What did I do with the bag of parts? So there are a couple of those little pieces that we're going to use. There's one. Where's the other one hiding? There it is. So we've got these little shaped pieces. We're just going to fit in and kind of lock things in place. This side, once again, is probably going to be a little bit difficult. Have to push on the back side some to get the angle right for that to pop in, and that's going to try and hold these in the appropriate spot or in the right angle. Same thing here. Push down, hold them in the slot. Or if there's two different sizes, this is just up. That side's very, very tight. This is a little tight, but that's because our things are at an angle. Be careful not to crack your acrylic or break your acrylic in the process of doing this. Here we go. There's going to be a tight fit. Or a non-fit as you throw the part around. I have no idea where that just went. Oh, sounded like it had hit. There it is. It, believe it or not, it bounced off and went onto the shelf, back of the shelf. Both of those are in now. There we go. We'll make it a little bit easier. We've secured our hose around with the straps. Got our connections going in here. This is where I said I may have left too much slack in these, being afraid of kinking them. So these may need to be cut down a little bit more, and the radius, or not the radius, but this length taken out of them some. Now we're going to locate the plug for this side. We installed the plug on this side. Now we need to prepare a length of nylon tube and install between this fitting and this fitting down here. I think I need, oh, Okay, so this is going to be our tube again. And once again, I'm going to put my tube in down here on the side, and then we'll bring it up. And I think it comes around. We take this, go around, or kind of makes it look like it goes in front of this tube. Nope, it goes behind. What I'm going to do is I'm going to push this in, feed it on the one end. So I have a nice clean edge when I do that. Okay. And then we're going to need to kind of figure out our bend radius. Where we're going to cut this. Kind of wish that there was like a defined length. Because I feel like I'm making these too long or too short or what have you. So it looks like we're going to have a kind of a guide piece that'll go there. I'm going to add that in before I do my little bend. That gets mounted with M3x8 socket head cap screw. Lower deck of our fastener kit. Got our little clamp. We're going to clamp it at a location that's hard to see. And even harder to put a screw in. But yeah, Westry, I've been printing with the bamboo, doing stuff for the Rook. I've had to print off a couple of parts here and there for some other projects. We've been building the VZ-Bot. So I've been doing my share. Okay, so we've got this connected in. Now on the right side, we need to connect this right side to the left side over here. This is going to be a longer run. Get that put in, and there's spots to mount some fasteners there. So we need to go ahead and get those prepped and ready. So we'll secure this tube in 2 places with 2 more M3x8s going through the back side of the panel. We want to be careful not to kink this as we bring it across. One, here goes the other. And of course this goes. And I'm clamping this as I go because I know I'm going to be tight on panels, or not panels, but on hose. So I'm trying to keep things tight and know where things are going as I finish off these runs. So probably there. Now, that's my issue, which is why I wanted to do this part, is I'm too short because I think I cut my X-Gantry longer than it needed to be. So I'm too short to make this connection back to the pump. So I'm going to need a source. Yeah, I'm way short. I'm going to need a source for this, or I'm going to need to talk to KB3D and see if he can send me more of the tubing, or if he can give me an idea of where a good place to get the tubing to be, so that I can make this run, which is going to need to come down through a clip here, then jog back up and go into. But we're there except for the one piece. My machine does not look like this because I didn't do the other 3 side panels because I'm not going to. Okay, Westry, enjoy work. So we didn't do that part. I'm out of the tubing, so I need to get some more of the tubing. No panel stuff. We're going to hold off on doing panel stuff because I don't want to enclose it any more than I have to right now. So we need to do the wiring for the pump here. Let me pull up the wire harness mapping. Ruh-roh. No, I had the wire mapping somewhere. Maybe it's over on this computer. It is. Okay, so this is the wire mapping guide that I was using. And as you can see, this is kind of small and tiny. The way it works, water pump, is it describes wire name, the component, so where it's coming from, what kind of connector that is, and then to what component it's going to, and what connector it is, what the length, so on and so forth. So for the water pump, radiator fan plus and minus. And then 12-volt plus and minus. Minus, positive. Fork, Molex KK, 2 of 2, 1 of. Oh, this is the electronics. Comes over here and it should be red, black, red, black. What I need to do is just verify on my connector, which orientation and color size. Bear with me 1 second while I try and get. Black, red, black. Okay, so we're looking good. Looking good. All I need to do is I'm going to depin this. I'm going to cut the wires with as much slack as I can, put micro fits on them, and then we're going to add it to this connector. These 2 wires just remain dangling. Nothing I can do about it. Hey, Pete, how's it going? How is it going, Pete? We are not as far along as I wanted to be. Partly because we started by taking this panel completely off and redoing a bunch of wiring. We redid wiring because at one part of the manual, it showed toolhead 0 being over here and toolhead 4 over here. Wiring guide, it's 0 here, 5 over here, and that is the correct thing. We did get that discrepancy fixed. Wiring fits better now that we've got that fixed as well. But it required us to basically undo a bunch of wiring and redo it. So that part sucked. Okay, so we're going to do Molex into, so female pin, male connect. Oh, that's right. You were working on the full life-size minion. Okay, like I said, I'm going to cut these right at the existing connectors so I get the most amount of useful wire, because I don't want to have to add any wire to this if I don't need to. Should be just enough wire to make this happen. This is the part of the wiring I was hoping to have done by this point, because I'm about 2 large coffees into the day already. A little jittery. Uh-oh. Girl needs to stop leaving poop on the build plate. So I don't feel like I've been running my bamboo for very long, but it keeps dragging poop onto the build plate. So I don't know if it's an issue where I don't think it's the cutter already. I think it's probably could be the wiper. I don't know. I don't know why it's doing it. But it keeps dragging its poop onto the build plate, and then it throws the detection error. And in this case, it's a single color print, but it was on the where it stops to do its check of the first layer, and it detected the stuff that it had drug onto the build plate. Me and these wires are not seeing eye to eye today. I should have worn my crimping ain't easy shirt today. Those two. Okay. So now we're black, red, black. I mean, it's cool that we're doing this in, a single connector and stuff, but I'm wondering if it wouldn't have been easier just to, do 2 runs. Just run 2 connectors out at the end versus trying to do it this way. Because we're still pretty tight. Right there. I think we're good. This is a pretty tight. We're good there. Righty. So where are we at? The water pump is now connected and tidied up. The still missing 1 water line, which is fine. Believe it or not, we can commission without it. We just can't fire up heat on the heaters because we have no way of cooling the heaters down. What else do we have done here? We need to do our umbilical cables. And we need to make a quick. Do we want the first 4 to be our Revos and the final tool head to be our V6? I think that would probably be better, huh? Is to have the first 4 as our Revos, and then our last one being the odd one out, so to speak. I think that makes the most sense to me. Especially since 4 Revos should be that much easier to. You know what? Why not? Why not? Why? We're going to do our first tool head, which I still need to do some work on. And umbilical wise, we need to stop losing my mind and jumping around, but switch over to here. Okay, so we're looking at our black box tool adjustment. We had done most of this before. Um, Probably going to be the most finicky tool head. I'm going to do these first couple of checks on my build plate. Because it gives me a nice good flat reference surface to go from. Position our tool onto the X plate. Where the tool lock is in the vertical position, so I need to lock our tool. Easier said than done, apparently. Tool is now locked. A significant angle difference. Ensuring that your tool lock is in the vertical position, place and hold the FDM tool onto the X plate. Using 2 steel ball pockets as a guide, this should require no effort and the tool should not stay in place without holding it. The tool should stay in place without holding it. Now my curiosity, trying to determine whether I'm vertical or not. I'm pretty darn close to it. The gap that I am seeing, shadow. Locate a printed tool in tension. There is no printed spacer tool. rotate the tool lock. Other thing I need to do is get my heater and thermistor set up for. That's not set up yet. So I'm just trial fitting this on the tool head. Then manually turning the gear, the worm gear, to lock it on the tool head. But because you can't turn the disc, you got to turn the actual worm drive gear. Won't be able to turn the actual tool gear with the worm in play. It also helps if you right direction. Do the M, two, two M3 by 18, push it forward, maintaining force against the tool cooler block. It is as forward as it will go. check and repeat, check and repeat, check and repeat. I'm going to have to turn this around to check and repeat, or walk to the other side, I guess would be easier. We're trying to make sure is that what we're trying to do is make sure that the cooling block is fully engaged vertically with the X-Gantry plate. If it's not, then you're not going to get the best cooling performance. Well, that's stuck. And I know that you guys are just staring at the side panel. So I will try and adjust that now that I've made a mess over here. At some point I should probably just glue this together so that I stop knocking this over. But that would be too easy. Okay, let's turn it around. Probably still not able to see. So I'm playing with the tool head here. Ooh. See if I can't grab this. Okay. There you go. So we're trying to make sure that the block is fully up against the X-Gantry when we have the lock engaged. I'm going to turn the worm gear. So we've got a lot of movement. So we're undocking our tool head. Right? Then we will redock our head. Turn our worm gear to redock it. Nice and firm. It's not going anywhere. Trying to look and make sure that it's perfectly parallel, that our water block is fully engaged on on both sides. And it's not at an angle. Can't see light, and trying to see if I'm seeing light or if I'm seeing a reflection. Sorry if this is hmm. I think I want to try that one more time. All right, Killer Dragon, see you later. Have a good one, my friend. Stay safe, stay out of trouble. Trying to push right in the center so that it will engage both sides evenly. Block. I think what I am seeing is actually a difference in the chamfer of the edge of the block. That should be fully locked. I'm not getting any movement whatsoever. Should hear a definitive click when this is in. Touching the water block. So I think we're good with that. There was no rotational play. sorry, I'm just reading through, and here's where you see 1 or toolhead 1 is the one closest to the water block, and 5 is all the way on the left here. You all seem to be sitting back appropriately. I will look at adjusting the whatchamacallit, the things at the bottom, the nozzle wipes. I will adjust the nozzle wipes a little bit later. I think I'm just going to play extra finicky with all of these and trying to get everything set up. The FDM tool umbilical, this has been kind of where I've been stuck at. So there are very few wire connections that connect directly to each tool. The totality, there are 4 connections: the Bowden tubing, the thermistor wire, the heater wire, and the spring steel wire. Right, during this guide, we'll be installing items 1 and 4, which is the Bowden tube and the umbilical. I'm sorry, the Bowden tube and the spring steel wire for the umbilical hoop. Working with spring steel music wire can be dangerous. With inherently sharp edges and unpredictable movement, it's important to exercise safety or safe handling practice. Begin by preparing a 1 meter length of Bowden tubing for the tool being installed. Only one end of the tube needs to be cut with a clean and square face. That side will interface with the tool. Prepare a 65 centimeter length of spring wire. Okay, so this is the fun part. This is where we need to actually measure out and get our spring steel wire in the appropriate location, or in the sorry, we need to measure out and get our spring steel wire straightened. One second here. Need to put away these so I don't knock them over and make a mess. And I want to put Blackbox down on the floor. First, move that over there, move that over there. So we're going to put Blackbox back down on the floor so that we can work with and adjust our spring steel. So give me 1 second to move some things around here. Camera's not going to be in a good position, but it is what it is. Because once again, there really is no clean or easy place to hold this, especially as you start putting panels on it. So just be mindful. Careful with your back. Make sure you tighten your core up before you do any movement like that. Especially if you can't, if you can't hold things really close to your body and lift right close to your body. As I'm having to do some of this, make sure you you engage your core and stuff so you don't hurt your back. Okay, so there is a video here. Hopefully this video works. And I'm not sure if you guys can hear the audio. I'm going to turn the audio up for me so that I can hear. But this is where we're going to need our thing, our vise. So it talks about taking your spring steel wire, and I've got several of these. I should have some extras. So we've got our spring steel wire. Now we only need 650 millimeters. Yeah, which is 65 centimeters. But we need to be cognizant of the fact that it's currently I was going to say sprung, but it's in a yeah, I guess that is right, a sprung state, or in a, yeah, it's in a spring state. So we need to straighten it out, and then once we get it straightened out, we can do an actual cut easier to 650 millimeters. Trying to plug in, because we've been going for a while, so I need to plug in the battery packs on my mic and receiver. We don't unceremoniously drop. Okay, we're going to take one of our packs. There we go. Here's my pliers go. Okay. We're going to take one of these. When we open this up, be very, very careful taking it out of the bag. Put your fingers on it. Put your hand on it. Those ends will spring out. These ends are most likely sharp. So be aware of it. We're going to want to take about ½ inch. All I'm going to do is I'm going to put it on the flat of my needle nose pliers, and I'm going to bend it over. So about the width of the needle nose pliers. And I'm going to bend it 90. Okay. That's going to give me a spot that I can put in my vise jaw. I'm going to do the same thing at the other end. Okay. One side is going to go in my vise. Is easier said than done because I've cranked on this vise. This is a cheap Harbor Freight vise, so bear with me. We're going to get our one end of our spring steel in the vise. Cinch down on that. The other end we're going to put in our drill. So we're just going to put this in the chuck of our drill. And then we're going to be unwinding it. It's a little bit easier or a little bit harder to get in here, so I'm just going to so sounds like we're going to kind of straighten this out. We're going to slowly go in the clockwise direction. It's about 45. I can still see some ripples in it, so I'm going to go a couple of more. We're at about 55. I'm still seeing ripples, but I had to go back 5. So it still seems like I got a little bit of a curve there. I'm actually wondering if I need to be going in the opposite direction this whole time, because this almost seems like it's gotten worse. I'm going to loosen this up out of my drill. And it's a little bit better, but it still has a little bit of a bend to it. Definitely not as much. Let's go ahead and chuck it back up and we'll do a little bit more. Once again, that just seems like it's either too much or something. I think that's about as best as I'm going to get this one. And be careful when you unchuck it from your drill. Bad. Not bad. Now, one thing to be aware of is this started bending right there. That's actually going to be good. Because once again, we need 650 millimeters. We need half of that, and we're going to mark the middle. So 650 half is what, 325? And if we come down here, we mark 325. Kind of right where that natural bend took place. Grab a Sharpie. So if we say that that natural bend is the middle, which is 325, then we can get it 325, come out here, and that's where we're going to cut this side. Okay. Then we're going to do the same thing. We're going to go find our middle mark again, put that at 325, go out the other direction. That's where we're going to cut this side. There's our extras. Start making a collection over there. And the reason that that's important and getting that kind of bend there isn't necessarily a bad thing, because we've got a tool here and I need to put a heat set insert in there. Put a heat set in there if there's no, there we go. Okay, so there is a tool here. It says to locate the midpoint of the 650 millimeter, so 350 or 325. Install an M3 heat set into this location. So we're going to put an M3 heat set in here real fast. And I'm just going to grab one of mine. This is a PLA part, so it's not going to take very much to get this set going. On a curved face, so just be aware you might have to work it down in there just below flush. Once we get one of these done, it should make it a little bit easier to do the rest and get the rest of these. Hey, Pez, how's it going? Oh, you have not missed coffee, Pez. We've had one mug, almost done with 2 mugs or 2 cups. And we got the backup that's been sitting in the Yeti. So you haven't missed coffee. You may have missed coffee, but we're still good on coffee. You're going to feed both ends of your wire into the slots on either side of this. You're going to try and pull them through in an equidistant fashion. Okay? Pull them through in an equidistant, close as we can fashion. And we're going to use just any given N3 flathead fastener. It's going to hold it in place and give us an initial bend. Once again, we're trying to make it flush, and then we're going to use our tools to give it an initial radii, which we're kind of there already. Flat is going to help pull this wire in and hold it in place. Ah. I want to cut the wire, I want to hold the wire. You're going to get your wire kind of the middle right there in that gap. This should hold it there. Use this, do a little compression. Forces the radius into the memory of the wire, supposedly. Assuming that is what it's going to do. So we're basically making our music wire. We straighten it and then we force it into a pump. Weren't 100% straight, but we're close. We're close enough. Hey, Tugboat, welcome back. So there's our initial wire. Not the prettiest, but we're there. We'll get better. We've got like 5 of these to do. So this is I'll say a very novel way to do this. Once again, as you're pulling these out of the package, be very careful. They are, it's spring wire. It is got a form to it, so you got to be careful of that. And we're going to take the flat meaty part of our pliers, fold that over to give us a 90-degree angle that we can put into our vise. We put one leg in this vise. We're going to come over and do the same thing at the other side. Put a 90 in it. This is the side that we're going to put into our drill. Clamp down in our drill. And now we're going to rotate using our drill about 40-ish revolution. And we're going in the positive direction, so clockwise to the right. So you want to go slow. 1, 2, that's about 30. You'll see that we still have a bit there. Wind it just a bit, get it straightened out again. A few more revolutions in the positive direction. Come back off of it some. Be careful as you're working with this. It does have a tendency to kink, does have a tendency to bend in on itself. You got to be careful of that. It is under tension. It is under tension. You want to be careful. You do not want to snap this and have it get you. And now I'm just trying to be careful and keep it stretched while it kind of gets its new memory for this length. As you can see, we're a little bit easier on that bend now. I'm not going to get it as straight as he did on the video, partly because I don't think, I'm not using piano wire. I'm using a spring steel wire. So I believe he was using a piano wire, but there we go. We're a lot straighter than the coil was. Got a little issue down here, but we only need 650 millimeters. So we're good up to that point relatively, ish. So we cut that, and we'll come down here and we'll just cut that 90-degree off, and that'll give us our 650. Now, be aware, you just cut these. These ends are now sharp. Be aware of that. Expect it. Stay safe. As you can see, a little bit of a wave in it, but we're pretty straight overall. We've got our 650 millimeters. We're going to mark 325. That's our center point. We're going to take both ends of our wire and get it started in our form. Just going to get it kind of through. I'm going to grab both ends in my pliers. Easier said than done. Both ends relatively close together in my pliers. I'm going to pull this down through. Get my end in the groove. We put in our M3 flathead screw. Get close, clamp it down. That is not clamping. Okay. This piece on. And I'm just going to hold it for a little bit. That's going to set that curvature. Now that we've straightened it out, we're going to set the curvature by just holding it there for a little bit. Been a busy day. Yeah. Lots of family things. Now, Liz, are you at home or are you visiting with family out of town, basically? Okay. And it's not going to be a 100% bend, but we're going to basically set ourselves up with a V. Okay. I'm going to continue. We'll do one more. That'll give us 3. I'll do the other 2 off stream. Then we'll bring, we'll clean this up. We'll bring the printer back up and I'll show you the next step. So kind of starting to get the hang of this. And on this, folks, you really need to be using safety glasses. Safety squints, as in squinting, does not work here. Protect your eyes. You only got one set. Be safe. One there. Come down here and do this other end the same way. Lock this up in the drill. Oofed. Yep. That's why you're careful. Okay. That is why you're careful. This lets go. That spring action springs into action. So, got it there. We're bringing it taut once again. Then we're going to slowly go forward about 40-ish revolutions. Okay, we're going to let it sit there with a little bit of tension on it to let it accept its new form. Then we'll rotate back about 5-ish. Again, I'm going to let it sit here and just relax a bit. Yeah, I was pretty sure she was visiting family as well, Mr. Wizix. I just was trying to figure out if she was in Nova Scotia or if she was in another part. So you see, as I'm moving forward, we still have a gentle bend there. Let's go back to the right just a little bit. So I did about 15 turns. I'm going to keep a little bit of tension on it. Once again, we're trying to let it get used to this new pressure that it's got, new form. I'm going to reverse it and take about 5 or 6 off of it. Let it sit there for a second, get used to itself. I'm going to go ahead and release it. I'm going to hold that end as I unchuck it, just to keep it from like snapping back and doing its craziness. And hopefully you can see it's now straight. Not trying to bend or do its own thing. Let me jump over here. Right? That's now straight. It's not trying to do its own thing. Not trying to, spring around into a circle. So there we go. I think the key is once you wind it, let it rest with the, maintaining tension, just let it rest. Then unwind it a little bit, let it rest. Just kind of cycle it a little bit, and that seems to be the good key. We're going to come in here, we're going to mark this at 650 or grab it at 650. Maybe just a couple extra. Cut it. Once again, this is extra, right? Because we only need 650. So come back in here and just about right there. Cut that edge off. Over in the pile. There's our 650. Take two ends, put it through the piece. And with the two ends together, I'm going to grab them in my pliers, really squeeze onto it. So I take this and pull it into the form. Then I can grab it right underneath the form and holding it with some pressure. It's not fully down into the form yet. Let me just continue to pull with some pressure. Just get it lined up and just hold on to this for a couple of minutes. Have a sip of your drink of choice. So that's coffee or what have you while this sits. Okay, fair enough. We're done. Now I can push our wire out. And we've got another V shape. If anybody wants to go looking for water, I mean, it might work. So we've now got 3 of those done. We're going to still need our yardstick, meter stick, whichever stick. This is a meter stick. Those over there. The other thing that we're going to need is our PTFE tube. So once again, we've got 3 meters, 3 meters of PTFE tube in each package. We're going to need a total of 5 meters. So same type of thing. We need to do our best to kind of unroll this, get some of the twist out of it. And we need a meter of this for each run, right? Pull this side up here. We need, begin by preparing 1 meter length of Bowden tubing for the tool being installed. Only one end needs to be cut cleanly. So I'm just going to kind of put this up against the edge of my mat there. Keep playing it out. To the 1 meter point. I'm going to kind of put this, mark it with my finger. Yes, I probably should have ran this through here because I'm going to use Steve's tubing cutter because it makes good sense. Why not? Do the clamp, push it onto the tube. Seriously? Push it onto the tube. Yeah, this should be the one that we had done before. So this should be a reverse Bowden tube. So it's 4 millimeter on the inside, three on the inside, 4 on the outside. Should be going in there just nicely, but it's not. I can wedge it a little bit and get it to open up some more. No, it's not. Put a kink in it. So, oh well, I guess we're going to mark and do this the old-fashioned way. We are looking for a semi approximate length. There's one. We need 3 of these for the 3 that we've got started. 1. Two. This should be a meter as well because we should have had 3 meters there. Little short. Little short there, Chris. That's good. I think I have plenty of tube, whether I can come up with the extra. No big deal. So we've got 2. I guess I can go ahead and make the rest while we're at it. Plastic bags, folks. You never know when you can use them. There's 3 links. Fourth. And I have a feeling this one's probably going to be short as well. Shorter than the first one. We'll have to talk to Chris and tell him that the other Chris probably isn't measuring worth a darn. Not a problem. Like I said, I've got plenty. So we've got our PTFE tube. We've got 3 of our wires done up. Did that. Now the next thing is insert the squarely cut end of the previously prepared Bowden tube in the coupling on top of the FDM tool. So move our little vise down. We'll trip on that 5 or 6 times later on. Move this over here. We drop this on ourselves later too. Clean up, move some things around. Because we need to put the printer up here, which is what I'm getting ready to do. So take these, set them over here, this over here, and we'll bring the printer up. Oh. Trying to get mentally prepared here. This printer is not light. Really no easy way to grab it. Oh. Everybody's still there. Good. So we're going to start off. We can pick a tool. Let me raise you guys up here. Got you over there. Let me raise this up. So we can see, and I'm probably going to just turn this around. See, let me rotate this around. Because we're going to be working with our FDM tool. So, do this, we'll do that. Go there. Awesome. We go here now. Okay. So I'm actually going to start over on this side and kind of work my way back. So it says to start off by putting your PTFE tube into your collet clip. So take your little blue clip out. Don't lose it. Square end of a PTFE tube. Push it down in there. All the way, all the way, all the way, all the way. All the way. Put the clip back in. Gracious. Clip back in. Here we go. Clips back in. Right? Now, you're seated completely. Insert a small tie wrap into the printed channel below in green and secure it, pulling the Bowden tube against the FDM tool part. So we're going to need a zip tie. And you're not going to be able to probably see very well, but we'll run the zip tie through there. And zip tie the Bowden tube to hold the Bowden tube in place. Get the tail off. All right. Next. Okay. Feed the other end of the Bowden tube into the pass-through bore in the dock to which this tool has been adjusted to fit. The length on either side of the tool dock spacer is not yet important. So all we're doing is we're going to take this and we're going to slide it through the hole in the tool dock spacer here. Of which I hope said hole is properly sized. And I'm not sure if it is. And I kind of want it to not be as tight of a fit as it was being. So once again, reverse Bowden tube, 3mm inside diameter, 4mm outside diameter. So let's grab our 4mm reamer. 4mm reamer is going through with no problem. So I'm not sure if there was just a tiny, tiny burr at the end or if this is slightly out of spec on the PTFE tube. But it's a little hard going in. Catching something, it's not going all the way through very. Still not going in very. Alrighty, so I'm going to chuck this up in the drill and very, very carefully because I know I've got wires down there. That would be bad. That went easier. I think that. All right, Chris, what is the trick here, my dude? Other than the fact that you're not here to help. What is the trick here? First button tube should be 4 mil. And it's about 4 1/4. First button tube is a little bit over, making it a little bit harder. Trying to make sure I don't go down too deep and actually hit something. May have to take these side panels. I am I'm gonna take side panels if I can see what I'm doing. Don't damage it. So These do need to come undone. And this here panel should be off because there's nothing holding it. These. Not coming out the bottom there. Since we're coming out and we're going through PTFE fittings, like I'm half tempted just to make these 5mm holes. This is kind of ridiculous that we're having this issue getting PTFE pushed through, and we're trying to, you know, there I'm through. The fact that this is, you know, a pass through and it's going to be attached. There we went through and I'm catching on the FDM panel or on the FDM board. So I push it out a little bit. There we go. There we go. I don't know how much length I need out the back, but there we go. I've got some length. We'll be able to come out the back. I think Chris said he comes out a couple of inches. We'll figure that out once we do the next step. Insert one end of the spring wire into the FDM tool bore, shown in red, and secure in place. So this would be taking our spring steel wire, and we want it to go down right here in the hole that's right behind the it's right behind the PTFE tube. And I may need to bring the tool off to make it easier to work on. And because I've got the hint of a hole, but it's, yeah, basically I just have the hint of a hole. So let's pull the set screw out, because the set screw, or not out, but back the set screw off a good deal. And then we're going to need probably the smallest drill that I have, because that hole, you know, that's the part of the print that was on the part of the print that was on the bed. So the hole itself is kind of sealed shut at the very top. So I've got a 1.5 here. Also got a 1. It could really, like, I guess, mic, you know, check the diameter of the wire, but all I really need to do is just break the top. Break the top surface, and that should get me the all I really need to get my PTF or the spring steel wire in there. Just break the top. Or not, as I just lost the whole together. Probably do this without the tool head on, without the PTFE in. I don't think it needs to really be that deep. Oh, gonna have to be off the tool head anyhow to get. Oh, definitely got to go down further than that. Oh, apparently I still didn't make the hole deep enough. Hey, Outer's Danger Den, how are you doing, my friend? Welcome in. We're having fun. We're playing with the tool heads, trying to get our tool heads properly established. I probably should have did this particular part like a while ago. What part is that, you say? Well, this would be the part where I'm trying to get the spring steel wire into the top far enough that the set screw will set against it and hold it in place. Oh, we're close, but am I still not deep enough? Like, what the heck? Be deep enough. That screw is only supposed to be just enough to snug it up, but how big's a set screw? That's the other thing. Set screw, M3 by 5 threads. There we go. We finally got it. So now we've got our PTFE tube. We've got our spring steel wire that we've added on there, right? Now we're going to wrap the spring steel wire around the bowed tube 4 or 5 rotations, as shown in the image below. Maneuver the bowed tube when positioning the peak of the spring where the wire we previously introduced a radius. So, say there's 1, 2. As you can see, we're going to need to push a lot more of this bowed tube through. 3 should be about at the top of the bowed tube. 4, 5, about there-ish, right? About there-ish. And this is going to get wedged down in this one over here. Raise the flathead fastener and the retention piece. So remember, these were the angled retention pieces that we had printed. Book stands for the Cat Place bookstore. Okay. I think these pieces might be kind of wedged in a bit. insert this down into the bore, potentially. Might have to go the other side so I can see. Just trying to hit a very small hole on the opposite side of someplace you're looking is really hard to do. What I do is try and get that. There we go. There we go. So this goes down in that bore. Not sure how far down, so we're going to go a little bit. We want to make sure we're a little bit down in there. Wedge will then go in there. Through. And as the screw gets tightened and pulls the wedge in, it should tighten up on that piece of wire and keep the wire from going anywhere. In which case that will also give us the proper size and bend for our Bowden tube. I don't think that did it the way I wanted it. Okay. That way just getting prepared for the next one. So wedge in, screw in, take it down flush. Well, I think the screw started pulling through the printed parts. So I may have to redo those a little bit. I don't know. We'll see. What it is it's pulling down that wedge there. And I think taking it out, getting the piece in there, and then wedging it down would probably be. We'll do that on the next one. We need to reprint a part and redo that one. I can do that one off stream. Here's the image for reference. Demonstrating the overall shape of the umbilical hoops when a given tool is docked. So here is yet one more piece that we're going to have to run through our back plate once we get there. So in essence, I need to do all five of these to get the back plate back on there without having to take it off, put it on, take it off, put it on, which kind of a pain in the tuchus. So with that said, let's do some more PTFE. Yay! One done, bunch more to go. Move the blue clip, hopefully without losing it. Push the PTFE as far down as it'll go. While pushing the PTFE down, put the blue clip back in place. Easier said than done with small fingers and area. There we go. We're going to put a zip tie in place. This just keeps the Bowden tube in the location and pulled back so it doesn't bend forward. And we've been going for quite a while, folks. About 6.5 hours. I am going to call a stream here shortly. I do want to thank everybody for being here today and hanging out with me. We continue to make progress on our black box build. It has been a fun day. We made progress. We've taken a couple steps back. We put things on. We've taken stuff off. But when it's all said and done, we're going to have ourselves a really cool print. See if we can. Nope. We're going to need to do some machinations. So before we do that, let me pop this off so that we can drill out the small hole that we need to for our set screw. And actually think I'm going to go with the next size smaller drill bit. Be a 1 millimeter, 1.5. If I can get it out. Tiny. And I can't because my drill will not close up on it. So smallest we can go is the 1.5, which is fine. Perfectly fine. Once again, I just need to open up this hole. I'm down in this area where the set screw can actually grab hold of it. Go ahead and do it to all the tool heads before I continue to get things in the way that makes it more difficult. Promise you, we're getting close. Next weekend we should be seeing final wiring and work on firmware setup. Wanting to get that done for all of these so then I can put drills away, we can grab the reamer bit and we're going to ream these holes out a little bit. We've determined that the nominal size of our PTFE tube is 4.2, which means we need to, 4 millimeter reamer is going to be a little bit too tight still. So we need to actually open it up a little bit more, but do so in such a way that we don't go all the way down and hit our board down there. Getting down there. And I am being very, very careful when I'm doing this because I don't want to go down and hit that tool head board and cause myself issues. Getting close. There's a part of me that, like, if I had like a 4.5 drill bit, I might be very, very tempted to drill through here with a 4.5. Like I'm right at the end, but I'm starting to hit where trying to push is causing me to kink it. Because the PTFE tube itself is going to be Um, like one, it's going to be through a fitting at the bottom, and then two, it's going to be um, protected. It'll be protected by the fitting. That thing, yes. There's a fitting that's going to protect it. So opening this up, other than the should not be a problem with opening this up to 4.5. Clean that up, but that will allow the tube to slide easier down in. Boom, I just came down and hit the FDM tool board. So let me grab a driver in the end and pull it forward from that. And see, we're going to have plenty of excess, so that's not a big deal. This piece will go down in there, and I'll have to pull this off in order to get this down in there and secured. Roughly the right facing direction. That screw goes all the way in. And that didn't grab. Apparently I need to go just a tad bit deeper. Go ahead and drill these while I'm correct thing would be to do that. And I'm being very, very careful. I'm going very, very slow. Now is not the time to screw things up. And what I've got to do here is just take the hole that I drilled. Like I said, it's the why are words so hard, chat? The holes for the set screw just need to be a little bit deeper. That's what I'm doing there, is just setting the hole in the set screw for the set screw. Then put this piece in, tighten that set screw down. And we'll be good. And it's just because this top part printed on this surface, so it kind of closed that hole up a little bit. Trying to open it back up enough that I can put the set screw in, capture the wire, and then we can wrap the wire around our PTFE tube to support it. There we go. So get this put back in there. Our wire going to wrap around our PTFE tube. Third one's going to be about the height of what our PTFE tube should be. 1, 2 more like that. Line this up in the groove of our other piece here. We'll screw this wedge down. That will lock in this side of the and there's 2 of our tool heads done. Probably have gotten 1 more twist on that. If we can get it out. Nope. All right, we're good. So boom, we've got 2 done. And I'm going to continue to work on the other ones off stream, so we'll have all 5 done by the time we come back from the break. So next Saturday, we'll have all 4 of our tool heads set up. I would have vacuumed out any of the stuff and cruft that we just did. Vacuumed out, blowed out, whatever. And we'll be ready to go on the next procedure, which will be doing all of the, finishing up the umbilical wiring, which is just literally connecting the cables. I'll go ahead and put the heater and thermistor into the E3DV6 hot end. So that one will be done as well. And it'll just be ready to start doing our actual configuration, software configuration. So with that, folks, I think we are done for the day or in the stream. Let's go find a good raid target, because we've been going for quite a while now, so there should be somebody on. Figure out who we got on. Got the Jerry Show, Maker Deck, Him for the Day, Foxen playing a game, Chris Perillo, Jeff Negan, Vile Mod, Stephen Poole. Anybody have a strong preference that's still with me? Here we go. Actually, you know what? We haven't been to the Jerry Show in a while. Let's go ahead and raid out to the Jerry Show. Check him out, see what he's got going on today. And we will come back to the stream on Saturday for this build. And yeah, we'll just keep on going. Hopefully that sounds good to everybody. I'm going to try and get 1 more twist in this come hook or by crook. Not sure how I'm going to do it, but I will get it there. May wind up just having to pull this back out. Manually shoving it back in. Just that's better. All right, folks, we're going to go ahead and raid out to Jerry. Thank you, everybody, for being here. Please join me as we head out to the Jerry Show. Next time we come back, we will have all 5 tool head umbilicals pretty much ready to go. We'll go ahead and connect in our wires, and we'll be starting on configurations at that point. Thank you, everybody, for being here. and we will see you all next time. Like I said, you may see me Monday because I am off Monday, but you'll definitely see me on Tuesday. Thanks, folks. Helps if I kind of give you a scene that makes sense, huh? Thanks, folks. Thank you for being here. And we will see you guys on Tuesday, Monday, possibly. Bye now.